work on solving single-step equations. So, here we have a single-step equation. We call it a single step because it takes one single step to solve this equation. When we have this equation, x plus 1 equals 2. I'm working under the assumption that you already understand that my x is a variable and holds the place for a value that we do not know yet. We know just by our knowledge that 1 plus 1 equals 2. We can already tell that x equals 1 just from our knowledge base. But I want to show you how to prove it algebraically. So when we're solving a single step equation, we need to set up our equation first. Here at our equal sign, we're going to divide our equation in half. So to do that, I like to put a dotted line that just shows that I have a left side and a right side of this equation. All right, when we're solving a single step equation, we follow a simple set of steps. The first step that we're going to follow is this. We're going to look for a plus or minus on the side with x. All right, we're going to look for a plus or minus on the side with x. The reason we're going to look for a plus or minus on the side with x is because we're actually doing our order of operations, our PEMDAS, in reverse order. Instead of parentheses, exponents, multiply, divide, add, subtract, we're going to do our add, subtract, then multiply, divide. So what we're trying to do is look for a plus or minus. Well, we have x plus 1. So we have a plus here. This tells us that we need to get rid of our plus 1 first. All right, so how do we get rid of it? Well, when we say get rid of it, what we actually mean is we want to cancel it out by getting it to 0. To get plus 1 to 0, we have to do the opposite of plus. The opposite of plus would be minus. So we would do the opposite of the add or subtract. So here we have plus 1, so we would say minus 1. Now, when solving a single step equation, something that happens on this side of our dotted line or this side of our equal sign must also happen on this side. So plus 1 minus 1 gives us 0, but in algebra it's not necessary to write the 0. So it cancels out and our x drops down because that is all that's left. 2 minus 1 is 1. So we have proven algebraically that x equals 1, which is a concept we already knew. Correct? So let's look at another one. Let's say that we have x minus 6 equals 12. All right, so again, solving a single step equation, we follow our first rule. Look for a plus or minus on the side with x. So x minus 6, do we have a plus or minus? Yes. We have a minus 6. So what do? We do the opposite of the plus or minus so that we can cancel it. Minus 6, the opposite of minus is plus 6. I forgot to put my little dotted line. And this is not necessary, but it just helps you keep track of what is what side. And when you do something over here on this equal sign, you just want to make sure that it mirrors on this side. Again, it's not necessary, and once you get to where you've practiced this a lot, this isn't really something that you have to do. You just realize that the equal sign has that. I like to put it, especially when you're first learning how to do it, just so that you can keep track. So I just wanted to explain that real quick. And on this side, we would do plus 6. So my negative 6 plus 6 gives me 0. And the 0 is understood. So those cancel and my x drops. My equal sign works its way down the line. And 12 plus 6 is 18. All right, so we can see that x equals 18. Prove that if we take our value for x, which is 18, and plug it into our original equation, that would be 18 minus 6 equals 12. 18 minus 6 equals 12. 12 equals 12. So we can see that this is correct. All right, let's look at one more. Here, I'm going to do 5x equals 10. All right, so here we have 5x. 5 times x, because we have learned that if a number is next to a variable, that is an understood multiply. There's no need to write the times. All right, so 5 times x equals 10. So let's follow our first step. We look for a plus or minus on the side with x. Do we have one? Well, 5 times x equals 10. No, we don't. So this brings us to our second step. Our second step is look for a multiply or divide on the side with x. All right? And again, we're going to do the same as we did with plus or minus, where if we find a multiply or divide, we will do the opposite. Of the multiply or divide. All right, so we're going to do the opposite of the multiply or divide. So 5 times x. The opposite of multiply would be divide. So what we would do is this. 5x over what we multiplied by. So we're going to divide what we multiplied by. And I'll tell you why in just a second. What we do on one side, we do to the other. So we have divided by 5. All right? Now, we know, and we learned in middle school and elementary school about fractions, and we know that 5 divided by 5 does not equal 0. 5 divided by 5 is 5 parts out of 5, which gives us 1 whole. All right? So, in this case, we are not necessarily canceling our 5's, because if our 5's canceled, we would have 0 x's, which is 0. Instead, what we're doing, when we divide by the number we multiply by, is we're going to write it as though they canceled, but they didn't. What happened was they became 1x. Okay? And we'll talk about that in just a second. My equal sign moves down the line, and 10 divided by 5 is 2. So we have here 1x equals 2. Now, this 1, just like if we had a 0, it's not necessary to write it. This 1 is not necessary. The fact that we have an x there tells us that we have 1. So we can get rid of the understood 1. X equals 2. That was solving single-step equations. Next time we will talk about solving multiple-step equations. All right.